The talk is about facilitating cooperation between firewall networks, and it's based on a lot of the experience we have in the UK, also based on the fall of the Winchcombe meteorite, which happened earlier this year. And that's a photo of one of the fragments of Winchcombe found in a field after a search by University of Glasgow, by Luke Daly and Mira Ehas of University of Glasgow. So I've called it What Just Happened because that's obviously the question you ask yourself as soon as Twitter starts lighting up and Instagram starts lighting up, and you check your cameras and you're just trying to figure out what happened. So for the mutual benefit of different networks, we can do two things. The first thing is just to share an event notification. So say, look, I got something, it happened then, did you get it? So really it's no more than just saying, I saw something. And then the next step is sharing data between networks. And so being rather contrary, I'm actually going to start with the second point first, which is sharing data between networks and our experience of Winchcombe. So this is the setup that we have in the UK. We've got 6 different networks, 5 different technologies, and all of them saw the Winchcombe meteorite arriving on the 28th of February. So we've got sort of going clockwise around this from top left, we've got UFO capture, a lot of sort of legacy systems that are run by 2 networks here. Global Meteor Network, which is expanding very rapidly in the UK. All Sky 7, which is Mike Hankey American Meteor Society system, which got some beautiful images, Winchcombe coming in. And then the 2 more institutional networks, Fripon, where it was caught on 3 cameras, and Desert Firewall Network, where it was also caught on 3 cameras. I mean, this was a very lucky meteorite fall. We had a wealth of data and we had multiple good triangulations of it. If it had been in a different part of the country, it might have been different. But the question is, once you've got all of this data, all mutually incompatible, what do you do with it? There's another look at the data we got. The strewn field is shown here in blue, and the bigger sort of field that we notified to the public is in red. And here are all of the different observations from the different systems. Now, the Fripon systems were in a nice line in the west of the UK, and the Desert Firewall systems were in the east of the UK. And so by about 5:40 in the morning after the fall, we had 2 really nice trajectories, but they were just slightly different trajectories because Desert Firewall Network was seeing it sort of head on, and Fripon was seeing it from underneath, and they weren't quite the same. By 8:25, we'd been able to send off all of the data from several of the networks to each other and exchange data. And by about 8:20 in the morning, we had a much better trajectory that had come from, calculated by Desert Firewall Network. So this image is generated by Hadrian de Villepoix. And this here uses the Desert Firewall Network data from here, the Fripon data from here, plus also Nick James's UFO capture data from there to give a really nice trajectory. What it meant was that by 8:25 in the morning after the fall, we knew it was of an asteroidal orbit, and the initial results had been that it might have been cometary, but combining the data meant it was asteroidal. We've seen an enormous amount of fragmentation, and so we thought we actually were on the hunt for something quite unusual and something that we wanted to get quite quickly, given all that fragmentation. There's what the data pool looked like, and we'd exchanged the data in the so-called Global Firewall Exchange format. So that's a series of extended CSV files or eCSV files, and some of the systems produce that in a native form. Others, we converted it to that, and then we're able to exchange that. And that meant that from the 16 cameras that caught the system, we end up with a single pool of data. So rather than, say, Fripon having 3 observations, Desert Firewall Network having 3, Global Meteor Network 3, each institution has a pool of 16 observations. Now, initially, of course, those observations won't be very good because they're automatically generated or quickly reduced. But by looking at the whole pool, you can actually pick outliers quite quickly and get an idea of where to focus attention for improving and point picking individual observations. I'll come back to details of the format and the implementation of the format in a minute. But just to sort of labor a point, the sort of traditional way of reducing Firewall data, and this won't go away, this is the proper way of doing it, is for probably one person or a small group of people to take all of the raw images, do careful calibration of all of the images, careful plate solving, and then point picking of the images, picking the centroid or picking the leading edge, and coming up with the trajectory and the evolution of the Firewall. Now, that means that if you're depending on a lone genius, you're also depending on that person not being on holiday or not being windsurfing or not being up the top of a mountain. And it can create real obstacles to fast response. So the advantage of actually having a common exchange format is that you become less dependent on an individual for an initial response. And also then you've got a pool of data and can collaborate on that. So I've tried to depict that here, that you've got for each of the different systems or sources of information, and that can also include dash cams or maybe even Ring doorbells or something else. If there's a person who has expertise in reducing those images, then they can feed their work and their brainpower into a single pool of observations. That's then available to whoever they want to share it with, and then everyone else can pick that up and actually do the analysis of it. And maybe this person here or this person here says, actually, the data you've got from Desert Firewall Network isn't looking good today. Why is that? And you can actually have a collaborative approach to coming up with an initial trajectory or coming up with the final analysis of the Firewall. So who's implemented this? We've got quite a list. It started off as a Desert Firewall Network native format that we're exchanging the data in, and slightly modified, and the modifications have yet to be implemented fully. Global Meteor Network have implemented it so that whenever there's a firewall in the RMS cameras, then it produces the eCSV file, so-called, which is in this format. With Fripon, Francois, you might want to comment, but I think there is an intention to implement it, but there's a lot of work going on the pipeline at the moment, I think. So we're using a converter for now. All sky cams planned, can read them, planned to write them, and Metrec fully implemented. Other systems, we've either had very preliminary discussion or no discussion. Being rather parochial, I've focused on systems that are in use in the UK particularly. And then hopefully, once we have that fully implemented, have people opting into it. Question is, where did this come from? And why did we select the Desert Firewall Network format? Well, last year I did a lot of work, quite widely consulting, looked at 8 different potential existing ways of representing single station firewall data, compared them all, wrote up a big paper, presented to EPSC 2020 a year ago, and Desert Firewall Network was the best of those. So there are a variety of reasons there, but rather than me rehashing that, I'll say that the original paper and our original presentation There's a link to them later on if anyone wants to go back over that ground. The format itself is here, so divided into 3 parts. Some headers here, which describe the tabulated data down the bottom. So that's about 13 or 14 lines of header. And then here, metadata. So your observation, latitude, longitude, elevation, and things like camera ID, the type of camera, the photometric band that's been used in the star catalog, and then details of the camera, sort of azimuth, elevation, rotation, all the stuff you'd normally expect to find, but all in this format. Why the curly brackets? Well, it's an AstroPi native format, but it also can be edited with a text editor or with Microsoft Excel. You've got a lot of choices to actually hack it if you want to. So it can take centroid or leading edge representation, multiple fragments, and it tolerates extraneous or absent data. And this particular example is produced by Metric, okay. If you want to implement the definition, then it's on GitHub, and the actual formal definition is written up there. There's sample data, so you can test your implementation. The background papers that I mentioned are there. And also we put a converter on there. So it can take 7 or 8 different data formats from different cameras and convert them to the standard format for Exchange. We've tried to be extremely conservative with the standard. So it doesn't change unless there's absolute unanimity. So far, there's a committee. Any network that implements it has a person on the committee. So far, it's 4 people of myself, Dennis Vida, Hadrian de Villebois, and Zerko Molau. And if someone suggests a change, everyone's going to say no, unless it's a really compelling change, just to avoid data becoming redundant. So that, very briefly, is about sharing data between networks. I'll now just give 2 minutes on sharing event notification between networks. And this came out of a discussion initiated by Luboš Nisselin following the May 2021 Firewalls conference. There was initially talk that all the networks should notify a central server, and then the central server should ping the networks to say that an event had happened. We decided that wasn't a good idea. That was, everyone had a different reason why it wasn't a good idea, but there was a consensus that it wasn't. So Mike Hankey came up with a really elegant solution, which is a peer-to-peer solution, where each of the networks basically publishes a list on its publicly accessible website. It's an insecure, public-facing website. And the list is as follows. Oops, gone. 2 things. One is an event log saying, and the example here is for Firewall, but saying which camera caught an event and when it caught it. And no more than that. And this is updated continually, and it's got the last 72 hours of data on it. And then have a camera location file. This is just static information. So given the camera code here, you can look up where the camera is and just see whether it's relevant to you. And it's no more than that. So if each network has that on its server, then other networks can log in and see, did someone else see this event? If they did, then you can talk about exchanging data. And again, we've written this up as a formal standard. It's on GitHub, written up in great detail, consistent definitions with the global firewall exchange format, and some sample data there. And so that is almost my 15 minutes up. The 2 things there, we've got to share event notifications. Something just happened. We've got an event notification protocol that Mike Hankey has devised, but the only network to implement it so far is the UK Meteor Observation Network. No one else has implemented it. And then the data sharing between networks, the single station captures are very clearly defined exchange format now. and is being quite widely implemented, and hopefully will become useful beyond the UK. So that is my talk.